sponsored by World of Warships. Hello again, I'm back in KSP. But why am I here? On Elu. That's kind of far away, isn't it? Yeah, it is. Worse, it looks like we're stranded here for the foreseeable future. Great. But how did this all happen? What led to our stranding on Elu? And where is Kevin? All good questions. Well, it all began when... Hello again, gents. Welcome back. Today, we're yet again back in KSP. In this episode, we'll be making great strides in not only sending Kerbals far away, but keeping Kerbals far away. In the last episode, the bounds of science and discovery were pushed very far. New technologies were discovered, large missions were sent to the far reaches of the solar system, and society has advanced significantly. This, however, came at a cost. Many Kerbals were unfortunately turned into a grey puff of dust in the name of progress. Jeb, Bill, Bob, Val, and in spirit, Urk and Obson, because I'm absolutely not getting them back. Sorry, Urk. They've all given the greatest possible sacrifice for the sake of the program. But we still have a long way to go. Remember, our goal is not to explore our planetary neighbours, but to explore our stellar neighbours, specifically Proxima Centauri b. In this episode, we'll be expanding our presence by building planetary bases all over the place. Not the dingy little ones we built last episode either. This time around, we're going for big lads. They won't just be bases, they'll be complexes, with their own power generation, crew quarters, mining operations, and even launch sites. Our first target is Minmus. So, let us begin. Gentlemen, this video is sponsored by Warships. Have you spent your whole life a stinky land-dwelling pleb? Are you itching for intense violence? Well, oh boy, guess what? I think it's time for you to hop on the computer, download World of Boat for free, and send some high explosives at the Japanese. Destroyers, battleships, cruisers, and aircraft carriers. A massive 400 warships, and 44 million players to send to the bottom of the ocean. But wait, there's more. The game is now partnering with Legendary Entertainment on a collaboration to bring Godzilla Vs Kong to World of Warships. What does that mean for you? Moke. Pick a side, shit lizard or giant gorilla, and unlock special rare camos, ship skins, and even Moke on the boat. Yeah! That's right, baby. D-Roar. Download using the first link in the description and use either Godzilla or TITANKONG for your promo code. Forget about Godzilla though, because Godzilla is a shit lizard. Enter code TITANKONG for 300 doubloons. 1 million credits, 5 days premium, the USS Charleston, 10 monkey-themed camos, or Godzilla camos if you're a shit lizard fan, USS Smith, or Tachibana if you're a shit lizard fan, and 3 Godzilla vs Kong ship crates. Gentlemen, you must act fast. This is an extremely limited event, so get your giant boat gorilla before it's too late. Offer ends 31st of May. Back to the video. So, Minmus. We're going to need a few modules for our base to be fully operational. Mining, refining, habitation, and a launch pad. But let's back up for a minute. Why build a base on Minmus? Hello class, it's me, Frog Guy. In this lesson, we're going to learn about drag. Aerodynamic drag. Drag is a force that acts in the opposite direction that you're moving. If I move to the right, then I'll experience a force to the left. It slows stuff down. Not what we want for high-speed rocket flight. Or is it? Yeah, most of the time. But parachutes are very useful because they can create huge amounts of drag when you want them to, slowing a speedy craft down to not so speedy speeds. But, most of the time, drag is bad. So how do we get rid of it? Well, if we can find a way to lower these guys on the right, it'll result in this guy on the left also being lowered. Maths. Now let's say, hypothetically, I want to have no drag whatsoever. Since all the terms on the right are multiplied together, and we know that anything times 0 is 0, if any one of these numbers here is 0, then the whole thing is also 0. These guys on the right here can't really be 0. Area would mean our craft is a one-dimensional line, the drag coefficient can never really be 0, and if you made velocity 0, well, yeah. Last we could change would be fluid density. Now this can actually be 0. Now I wonder, where is fluid density 0? Kevin. Someone. Please tell me. Really? No one? Guys, come on, it's Minmus, you fucking idiots! I've had enough. God, why would you just pay attention to what I... Yeah, Minmus. there's no atmosphere, meaning drag is 0. Good spot for a base, don't you think? Yes. So we want to build a base. What do we launch first? Simple. 3 things at the same time, because otherwise we'd be here for far too long. The main habitation module, called Djibouti, the beam sections on the side, called Djibouti beam section, and the crane. Except the crane didn't work, so we went for this thing. The amazing, the incredible, Big Nuts. Big Nuts will attach the beam section to the habitation module. So, let's launch.
3, 2, 1, go!
And they're all here. After several minutes of futzing around with Big Nuts and a couple of Kraken encounters, the beam sections were fully assembled. So, what next? Well, we're close to completely out of funds which are needed for expanding the base. So what do we do? A. Collect some easy money by completing contracts. B. Sell off some science and reputation for a quick fund boost. Or C. Liquidate all capital assets and divert the funds into a multi-billion-dollar joint venture with Amin Hassan Nasser, president of Saudi Aramco Petrochemicals, to build the largest, most powerful, and most profitable chemical refinery ever built. I think the answer is pretty clear. After an hour of turning ore into monopropellant, or cash into more cash, we have arrived at 5 million funds, more than enough to make the rest of the modules for the base. However, we have a problem. It turns out where we put the base is quite important. There are 2 main resources we need for it to function. Ore, which is used to make fuel, and metal ore, which is used to make metal, which is used to make rocket parts, which is used to make rockets. Our current spot has ore, but no metal ore. So I did some prospecting, found a good spot, built a sky crane, flew it to Minmus, picked up Djibouti, and flew it about 20 kilometers east. Our new spot is rich in both ore and metal, but it's not flat and tends to cause, problems. To complete the base, we need a drill rover, a refining rover, lots of these attacher things that are unnecessary if you aren't stupid, and finally, the launch pad. And there we go. In celebration, we build a fuel tank, and a dish, and a station. Why? Well, as my new Saudi friends would tell you, because we can. This Minmus base will be our new point of rocket launching, and our first mission from it will be Gilly. If you think Minmus's 0.05 G is far too much gravity, try Gilly with its 0.005 G. That's 10 times lower. Not only is the gravity incredibly low on Gilly, but it's quite far away, so being able to build things there is a big, fat dub. This time I'm going to send a single rover that can do all of the functions of the Minmus base, but badly. This rover will be the start point for yet another base. Its name?
Juan.
Instead of launching from Kerbal with a huge annoying launch vehicle, we can simply build it on Minmus and ship it to Gilly from there. Not only will this be easier, but it also won't cost any funds at all. Not that that matters. After a painful construction process, it's on the pad, fueled up, and ready to launch. So, let's launch. There we go, boys. One has landed. As a test, I quickly whip up a small science rover, build it up, and drive it around. However, around this time, this started happening. What? Repeatedly. I switched to the minimus base, and then this happened. Oh shit. Not good. Luckily, I had turned quick saving and reverting back on because of this exact bullshit being a possibility. So the bases weren't gone, but they were kinda useless in this state. Dang. So for the next base, I decided I would... For this base, I've made the executive decision to launch it from Kerbal. I had a plan for this particular vessel, and it was big. Luckily, our boys at Saudi Aramco had been pumping and dumping non-stop for the past several months, netting us a very, very large amount of funds to work with. 26 million to be exact. Excellent. This would be necessary, as this next base would be quite large. So large in fact, that 26 million wouldn't actually be enough money. Now, we could have continued to convert Kerbin's crust into monopropellant until we reached the planet's core, but that would be boring, and I know we can do better. What we needed to do was find a different resource to sell. You see, our great, strong partnership took boring old ore and converted it into boring old monopropellant. This would be the most efficient conversion without mods, but we have mods, so let's use them. Behold, the different resources of KSP Interstellar. There are a lot of these, and some of them are worth quite a bit of cash, but one stands above the rest. Antimatter. 1 kilogram of this stuff is worth a ridiculous 108 million funds. However, we can do even better. This is the Diamagnetic antimatter container, which doesn't just store antiprotons, but full antihydrogen, which you can store with much higher density. In fact, right here, you're looking at 1,000 kilos, or 1 ton, of antihydrogen, which is worth 108 billion funds. Now that is a lot of dollar. So, let's partake in the ultimate drug run, and go fill it up. But first, what is antimatter? Hello again, class. Welcome back. Particle physics. Sounds complicated, but it's really not that bad. Firstly, we begin with water. If you were to zoom in really close to water, you wouldn't see anything. But if you could see something, you'd see water molecules. Lots of water molecules. Let's pick one of these molecules and look at it even closer. At this scale, you can see that water is made of 2 hydrogen atoms and 1 oxygen atom. H2O. Let's ignore the oxygen for the time being and zoom into one of the hydrogen atoms. At this scale, we see that the hydrogen atom itself is made of 1 proton and 1 electron. Protons have mass and a positive charge, and electrons have almost no mass and a negative charge. Protons and electrons, and also neutrons which have no charge, make up matter. If we have a close look at oxygen, we see that it itself is made of 8 protons, 8 neutrons, and 8 electrons. So where does antimatter come in? Well, it's basically the opposite of regular matter. Antiprotons have negative charge, and anti-electrons, which are actually called positrons, have a positive charge. This means that antiparticles and regular particles are attracted to each other. So, what happens when they touch? Annihilation. All their mass gets converted to energy by Einstein's famous equation E equals mc squared. E being energy, m being mass, and c being the speed of light, which is squared. C squared happens to be this number, 9 with 16 zeros on the end. So if you had 1 kilogram of antimatter and mixed it with 1 kilogram of regular matter, you'd have this number of joules. A lot of joules. Or 21 megatons of TNT in 1 kilo. Pretty good stuff, which means our lovely 1 ton of antimatter is the equivalent of 21 gigatons of TNT. Very big, but still 5,000 times less than the Dino Destroyer asteroid. Now that was a big boy. Back to the challenge at hand, collecting antimatter. Challenge number 1. You can produce antimatter in Kerbin, but it's difficult and slow. Not ideal. The other way to get antimatter is through using a collector. In space, there's actually a fairly large amount of antimatter just floating around. If you're smart, you can use strong magnetic fields to capture this antimatter and store it. This is great, but it only works in space, and works best near strong magnetic fields where there are lots of particles whizzing around. Kerbin has a magnetic field, but it's quite weak. So do all planets in KSP. But they all suck compared to our big green friend, Joule. At exactly 9,000 kilometers in altitude, on a perfectly circular, 0-degree orbit, you can get the highest possible antimatter flux. You can also stack up collectors and start collecting in the tens of grams per hour. Big stuff. However, there is another problem with this method. The collectors can only collect antiprotons, not positrons, which can only be created in a cyclotron. So, we need lots of collectors, a cyclotron, a power source, generator, radiators, and of course, engine for getting to Joule. Behold, the Warren Buffett. Let's strap it to the most powerful rocket ever built, and send it up. Once at Joule, we place ourselves at 9,000 kilometers, start producing positrons, and begin the lengthy collection process. And after a mere 6 years of spinning around the big green boy, the container was filled with a ridiculous 1 ton of antimatter. Time to bring it back to Kerbal. After another 2 years in space, the massive bounty of antimatter is finally back. So we recover the vessel and are rewarded with 96 billion funds. Very good. Now that we will never have money problems again, we can begin construction of our largest project yet, the Joule spacecraft. Since it's going to be so large, launching it in one go would be infeasible. So instead, the program has decided to launch it in several smaller chunks and perform what is known in the business as Orbital Assembly. This would require many launches, but once assembled, we would have a real big boy in space. Not just any big boy either. This would be a proper spaceship. Lots of fuel in these spherical tanks, this big fusion engine for high efficiency, a nuclear reactor for power, a ring centrifuge particle accelerator thing that looks cool, and a lander for collecting surface science. But before we launch, learn time. Let's rewind the tape a little bit. This big fusion engine for high efficiency. What do I mean by this? What makes a rocket engine efficient? First of all, let's look at a small example. These two rockets are both exactly 7 tons and have the same amount of fuel. The only difference between them is the engines they use. This one uses a conventional liquid fuel engine, and this one uses a nuclear engine. If we burn all the fuel in both rockets, which one will be going fastest at the end? The nuclear engine. Obviously, why else would we put a nuclear reactor in space? You dumb! So why is this? Conservation of momentum. You may remember back in episode 1 when I asked Kevin about Newton's third law. Every action has an equal and opposite reaction. The rocket engine expels hot gas backwards very fast, which imparts an equal and opposite force on the rocket, causing it to accelerate. If you throw the hot gas back even faster, then you get more force for the same amount of fuel. This is exactly what the nuclear engine is doing. It uses a nuclear reaction in its core to heat up a gas to incredible temperatures that are much higher than what normal chemical rockets can achieve. This hot gas expands more than regular hot gas, which gives it higher exhaust velocity, and thus higher efficiency. So what about our futuristic fusion rocket? How does that work? I don't know. But what I do know is that it uses a nuclear fusion reaction to release lots of energy and then shoots hydrogen through it to get its thrust. Efficiency is measured in specific impulse, which is measured in seconds. Higher seconds is better. But why seconds? 400 seconds would mean that a rocket engine with 100 kilograms of fuel would produce 100 kilograms of thrust for 400 seconds before it ran out of fuel. The best chemical rockets can do about 400 seconds of specific impulse. The nuclear rocket engine in stock KSP does 800 seconds, and the ion engine can do 4,000 seconds. This is still baby shit though. The fusion engine that we've been talking about can do 15,500 seconds in high thrust mode, and 27,000 seconds in the most efficient mode. But we can do even better. The best engines can do 100, even 200,000, with the very best able to do a ridiculous 2 million seconds of specific impulse. These engines are so powerful that they can realistically accelerate the craft to a significant fraction of the speed of light. Very nice. Anyway, back to the dual mission. We've got a few modules to launch: propulsion, command, centrifuge, reactor, habitation, labs, new labs because the old ones are bad, and the lander. So, let's go. Once the spaceship was fully assembled, I went to give it a name. But what to name it? Something that is definitely the Big Funny. I consulted the world map, zoomed into West Africa, into Burkina Faso, and to its capital, Ouagadougou. Immense. Once around Joule, we placed the craft into a parking orbit, detached the lander, and began the hunt for lots of science. Lots of data was collected, and our fuel was almost depleted. We headed back to Ouagadougou, docked, and transferred the science into the lab. After several more months of zooming around the green boy, the research had been completed. In total, we had collected 41,000 science from our mission, but the labs had multiplied this by 5, leaving us with an absolutely massive 207,000 science. In celebration, I get a Kerbal out of the habitation module, who is instantly vaporized by the high-energy neutrons from the fusion engine. RIP. I hurried to the R&D building and unlocked every technology available, including the warp drives. Our next base will be on the surface of the furthest planet in the Kerbal system. Good old Eeloo. I've learned from our previous surface-based mistakes and placed everything necessary for the base to function on one vessel. Its name? This long boy has the premier in power generation, a literal black hole, and many other important features like a launch pad, drills, and an ISRU module. The interesting part of this base is how we're bringing it to Eeloo. You'd expect for a rocket of this size it would need a massive launch vehicle, but no. With our shiny new technologies, we can condense this vehicle into this power node. It uses 4 antimatter powered jet engines, a massive fusion engine, and the warp drive. So let's launch. Up in space, we don't bother getting into orbit. Instead, we begin charging the warp drive, and... "20 minutes later, we've travelled 76 million kilometers and we're here. We take it down to a low orbit and touchdown. In less than a week, we've placed a base on the furthest planet in the solar system. Very nice. In celebration, we build a space station and launch it from our base. Incredible. We've pretty much conquered the entire solar system, so naturally, our next destination is... For our first interstellar voyage, we'll send a lander to plant a flag on the planet's surface. This will need an interstellar transfer stage, and a lander with enough delta-V to land and return to orbit. For this job, we've recycled the Ouagadougou lander, remembered to include a ladder, and built the very first interstellar transfer stage. So, we put it on a launcher, name it Shitfart 14, and launch. Once in space, we charge up the warp drive, and... Here we are, boys, Proxima Centauri, and our small exoplanet, Proxima Centauri b. We detach the lander and fly it down to the surface. World of Warships.